only the mean you can compare by Z test. We can compare the proportion, two proportion, whether equal or not. So here there is a question. This is the from the research paper I put it for you. So there is a question from the Time magazine. There are 800 adult Americans. So one group is non-smoker and one group is smoker, and the government want to increase the tax. So for the healthcare reform. So what is the smoker said and non-smoker said? So from the smoker, that is, if you say take a sample of, for the non-smoker took a sample of 605, and 351 said yes, they want to increase the tax for cigarette non-smoker, and which is 58%. Okay, and the smoker 41 out of 95 say they want to increase, which is 21%. So we want to test by 1% level of significance whether the two groups differ significantly or not to increase the tax. Okay, this is the question. So we have the two groups of people, smoker and non-smoker, whether they differ significantly. We know there is a lot of difference between the two groups, but statistically we want to prove it. Okay, so statistically we want to prove, scientifically, I told you, statistics means science. Scientifically we want to prove it. Let us try. First of all, as you say, we have to say two groups had the same opinion, same proportion of opinion. Let us see. The first of all, we have to agree. Okay, first of all, we have to agree that the two group, smoker and non-smoker, had the same proportion to increase the tax. They have no difference. Both of them increase the tax. And alternative hypothesis, we have to say no. They have the difference of proportion among the two groups. So first step, we have already formulated H0, H1, null hypothesis and alternative hypothesis. Always null hypothesis, we have to say no difference, they are same. But alternate hypothesis, they are not same. Okay. And the step 2, we know level of significance. It is already given 1% level, 0.01. Okay. And for the two sample proportion test, first of all, you have to find a pool proportion, which is P cap from the two sample. Y1 is the yes for the one sample who are agree, and Y2 is the yes for the Y2 sample, and the N1 plus N2 we know sample size of the two group. If you put all the value, you will get the pool proportion, which is 0.049. So and the formula for the Z test for the proportion difference, P1 minus P2 minus P0, and that is the population proportion maybe, but here P0. Put all the value and the divided by the pool proportion, multiply 1 minus P, and this is the formula. Please remember the formula. If you put all the value in the formula, you will get the value of Z is 8.99. So putting all the value, please remember for the two proportion, you have to find a pool proportion for the yes of the two group. Okay, remember the formula, and you will get it after putting the value in the Z. You will get the value of Z 8.99. So for as it is two-tail test, alternate hypothesis not equal, we have to take the plus value. So it is plus value, so our absolute value also will be 8.99. Step 4, by conventional method, we know that 1% level significant, the tabulated value of Z is 2.57. You can remember for 5% it is 1.96, and 1% it is 2.57. So our critical region will be greater than 2.57. This is step 4 to define the critical region or find the p-values. Here we did the critical region. So if you do the critical region, it will be 2.57. Now what is our decision? Our value of 8.99, which is far more greater than 2.57. That is our calculated value falls in the critical region. As it is false in the critical region, we do not accept the null hypothesis. Remember, when false in the critical region, that is the rejection region. Critical region means rejection region. When our calculated value falls in the critical region, we do not accept the null hypothesis. We accept the alternative hypothesis. That is, we can say at 1% level of significance, that is the opinion of the two group, smoker and non-smoker, differ to a tax increase, which will help for the health care of the reform. So it is normally you get from the data differ by statistically, or you can say it is highly statistically significant that the opinion of two groups, smoker and non-smoker, differ for increased tax for healthcare reform. Okay, so this is the way. I think a p-value method is given or not. Let us see the yes, p-value method. If you calculate the p-value, it is almost will be near. Okay, so I calculate this p-value from the R programming, but let us try to calculate the p-value in the Excel. Okay, so Excel, let us try. It is not given. It will be probability that is z1 greater than 8.99. Okay, so it is will be almost 0. 8.99. Let us try in Excel. Okay, let us try. It will be to understand as it is not given the table, because table is 3.49. So let us try in the Excel. Okay, let us try in the Excel sheet. Let us try in the Excel sheet where our okay, this is the Excel sheet. Okay, now I want to find the p-value, that is p-value, that is probability z greater than 8.99. 8.99. Okay, how can I get it? I told you, you have to give it 1 minus, say, how can you get it? Equal sign, then 1 minus normal standard deviation, and if you give NO, okay, you'll get it normal standard distribution, NORN. So you have to click it. Okay, and what is our Z value? Because minus, it is greater than, we have to give 1 minus. Okay, if less than, you can get directly. What is the Z value? 8.99, and you have to set true because we are taking the cumulative frequency. Okay, from minus infinity to 8.99. Okay, true, click the true. So if you give it, okay, if you do it, it is almost 0. If you take the more, it is almost 0. So if you do it, let us do what is the actual value. Okay, so if you do it for the number, if you take it up to the 10 digit, what will happen? See, if you up to 10 digit, we are getting 0. If you take more digit, what happen? Let us test. Interesting. 20 digit. Okay, if I do 20 digit, okay. See, if we do the 20 digit, what will come? Instead, we are getting 0. See, it is almost 0, very, very less. So even Excel cannot see. So it is almost near to 0. So let us go to the original slide. Let us see. So for the value of this, so for the value of, so we got it almost 0. So as it is less than 0, which less than 0.5, 1%, 5% level of significant. So sorry, it will be 5% level of significant for you. So after correction, as our level significance is given 1%, 0.01. So as I told, if p value less than the level significant, we reject the null hypothesis. So our p value, which is near about 0, which is less than 0.01. So we reject the null hypothesis. There is sufficient evidence, you can say, or it is highly statistical significant that the opinion for the two group, smoker or non-smoker, vary for increase the tax, which will help for the health reform. So this is the p-value method. I told you, if you get both results same, if you do conventional method, is also fall in the critical region. We do not accept the null hypothesis, and difference also in the p-value method. Also we get the two value, two opinion between the two groups differ significantly. So this is the p-value method.